energy stored. Hamza, have you got the assignment from the portal?
Sorry, sir.
Uh, um, I am saying that have you got the assignment from the portal?
Yes, yes.
Have you completed that?
No, sir. I completed, but before submitting this video, it expired.
Actually, your voice is not clear. Hamza, you can write on in the chat box about the assignment. Okay, no problem. That's fine. So you can do the assignment, this same assignment in the next class. Yeah.
Okay.
Okay. Expired. Okay. Okay. Fine. So I am not discussing the assignment today because energy is stored in parallel plate capacitor. Energy is stored in parallel plate capacitor. Okay. Now that from this here, the derivation of this energy stored is not in your syllabus, so we will only discuss the formulas and numericals. So this is a parallel plate capacitor. Initially, this have no charge on the plate. Initially, no charge on the plates. And when we have connected this capacitor, the same capacitor with a battery, So what the battery will do? Battery will provide the charge to the capacitor, means battery will charge the capacitor. So this is the positive plate of the battery. So means from this plates become positive charge, get positive charge, and this plate got the negative charge. Okay, positive, 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 negative, and so suppose you by the battery Q charge is given to this plate and minus Q charge is given to this plate. Q is the maximum amount of charge given by battery. Maximum amount of charge given by battery to the capacitor. So this is the charging of capacitor, you can say. Initially there is no charge on the plate, but when we connected this capacitor and air is in between the plates of the capacitor, this battery give the charge to the capacitor. this is a positive terminal of the battery. This will give positive charge to this positive plate and negative charge. And due to this charge, when the battery is giving this charge to the capacitor, means there is some work done. Battery is doing some work in giving a charge to this capacitor, and this work done is stored in the capacitor in the form of energy. You can say potential energy, and that energy we have the formula for that energy. The, and that energy is represented by capital U. U, that is capital. So the formula for capital U is Q square divided by 2C. Q, you can say the maximum amount of charge given by battery or charge given. You can simply say charge given, or you can say charge holding by capacitor. Charge hold by capacitor. And C is the capacitance of parallel plate capacitor. So this is the one formula. This is one formula. This is the formula. I am not driving this because derivation is not in your syllabus. And if I place, we know Q is equal to charge into potential. If I put in U instead of Q, it's CV, this will become C square into V square. This will become 2C. So finally this will become half. C and C got cancel out. This C and this cancel out. So we will get half CV square. This is another formula. And one thing more, V is the potential difference. V is the, you can say, voltage, and voltage is also known as potential difference between plates. This is another formula of capacitance or of energy. And if I put the value of C here, C is equal to Q by V. Now put C here, you get U is equal to half. This is Q by V into V square, and this is cancel out. So U, capital U, this is equal to half of QV. And this is another. So we have three formulas. We will use these formulas according to the requirement. You can only learn these two. You can only learn this formula, and you can derive this formulas easily. Now there is another term, energy density. Energy density for parallel plate capacitor. Okay, energy density for parallel plate capacitor. So energy density is represented by small u. And the formula of energy density is energy stored, that is capital U, divided by volume of capacitor. And volume of capacitor, if area of capacitor, we have already discussed, A is the area of each plate and D is the distance between two plates. So volume will be A into D. Area into D will be the volume. So put these value. U, put the value of U. This value. Q square upon 2C is U. Q square upon 2C is U, and put the value of volume AD. Okay. Now what I am doing, this is Q square. Now I am putting the value of C. What is the value of C when two plates are separated in air? Two plates of capacitor are separated in air. This is the value is of capacitance is epsilon 0 A by D, and this is dA, and D is cancel out. So small u is become Q square divided by 2A square epsilon not D. 2A, not D, 2A square. This is 2. This is A square. D is D and D cancel out, and this is epsilon naught. And Hamza, we know sigma is equal to Q by A. So I can write sigma square is equal to Q square divided by A square. So instead of Q square by A square, I am writing sigma square. So now this becomes sigma square divided by 2 epsilon 0, and now I am multiplying it with epsilon 0, and it will become sigma square divided by 2 epsilon 0 square into epsilon naught. And I have told you that total electric field in between the plates is sigma by epsilon naught. We have discussed this. And E square is equal to sigma square divided by epsilon naught square. So small u, that is energy density, will be, this is half, and this term will become E square. So I can write it epsilon naught into E square. So this is the formula for energy density. This is the formula for energy density for parallel plate capacitor. For parallel plate capacitor. So Hamza, please write it down. This is very easy things, as derivation is not in your syllabus. So this is good for you. Hamza, please note it down.
Yes.
Hamza, should I scroll down?
Yes, sir.
Completed na?
Yes.
Hamza, should I scroll down?
Yes.
Please note it down. You have completed till here? Okay, good. Means you have completed this all. Now force between plates of capacitor, parallel plates of capacitor. So this is one plate, this is another plate. This is positive charge plate, this is negative charge plate. So we know that from a positive charge plate, if I want to calculate the electric field here, means on this plate, so the value of electric field will be sigma by epsilon naught, sigma by 2 epsilon naught. So you can write here, this is, I am supposing this as plate 1, this is plate 2, and this have a charge q and this have a charge minus, and we know that these are these plates have equal charge, so they will attract with some force, with equal force, and this force is I am representing as F, force of interaction between two plates. Electric field due to plate 1, the value is constant everywhere. This is E equal to sigma by 2 epsilon naught. And now here the electric field is E and this charge is in this electric field. So electric force is equal to charge into Q into electric field, sigma divided by 2 epsilon naught. And what is sigma? Sigma is charge upon area. So you can write minus Q multiplied by Q divided by 2 epsilon naught A. We are calculating only magnitude, we know the direction, so we can remove the negative sign. So the answer is force between two plates Q square divided by 2 epsilon naught A. This is the answer. So Hamza, please note it down. Done. Very good. So this is the force between two, as we know that the yes, of course, we are doing numericals now. I am giving you the numerical. Okay. Next is numerical. Please have patience. Okay. So we know that the because without the concept you cannot solve the numerical. No. Now you will see we will use all the formulas in this numerical that we have studied. So the plates of, and this is also a numerical, but I have converted it into heading. Someone can ask you find the force between the plates of capacitor. The plates of parallel plate capacitor have an area of 90 centimeter square each and are separated by 2.5 mm. The capacitor is charged by charged charged by a 400-volt supply. The first question is how much electrostatic energy, how much electrostatic energy stored by capacitor, stored by capacitor. So means they are asking capital U. They are asking capital U. And second number and question B is calculate the energy density. Calculate the energy density. Now, Hamza, you can see this. If we have not derived this, how can we calculate the energy density? That's why I have written all these things. Okay. So please think this question. How we will solve this? How we will solve this question, Hamza? Okay, so no problem. We have to calculate this now. We have three formulas. We have three formulas. Answer A. We have three formulas. Like U is, first formula is Q square by 2C, half CV square, and half QV. So see here, we do not have Q. Q is not given in this question. Capacitance we can calculate capacitance by epsilon naught A by D. So this is QV. So what formula we will use? We will use this formula. Why? Because we have capacitance and we have potential. So U is equal to half CV square, this will be used here. This is the approach. So you can calculate C. C is epsilon 0 A by D, epsilon 8.85 into 10 to the power minus 12. What is the area? 90. Convert that into meter square, 10 to the power minus 4. And D is 2.25. 2.5 or 2.25? 2.5. So convert this in meter. 2.5 into 10 to the power minus 3. Minus 3. Then C. Hamza, can you calculate this for me?
Yes, sir.
Into 36 and into 10 to the power minus 13 farad. So okay, you can calculate it later. So means now we have capacitance C. So we can calculate U. Half, put the value of C. 8.85 into 36 into 10 to the power minus 13 into V square. What is V? 400 square. So this is the value of U. Electrostatic energy stored in the capacitor. You can calculate this. First question is solved. First question is solved. Now we have to calculate the energy density, and we have the formula for energy density. This half epsilon naught into electric field square. Energy density B. Energy density means small u half epsilon naught into E square. We have epsilon naught. We know the value of epsilon naught. It is 8.85 into 10 to the power minus 12. But we do not have electric field. And I have told you, Hamza, many times, the value of total electric field inside the plate of capacitor is sigma by epsilon naught. And sigma is charge upon area. So for calculating the electric field, we have to calculate the charge. We have this, we have this. So for calculating the charge, what we will do? This is the for calculating. We have to calculate this. For this, we have to calculate electric field. For electric field, we have to calculate charge. And how we can calculate charge? We have energy. We have energy is equal to half. You can calculate from this half QV. Half, and this value is given. This value, what is this value? This value is given half into 8.85 into 36 into 10 to the power minus 13 into 400 square. You can see here by a supply of 400 volt. And here we have half QV. Half, we have to find Q, and we have the value of this 400. And from here you can calculate the value of charge. So charge will come out to be like 8.85 into 10 to the power into 72 into 10 to the power 13 minus 13 coulomb. You can calculate it by yourself. So we have calculated the charge. Now we will calculate the electric field. Now we will calculate the electric field. So electric field we have calculated here sigma by epsilon naught. Sigma by epsilon naught, and that is given by Q by epsilon naught A. Q by epsilon naught A. So put all the values here. Put all the values here. 8.85 into 72 into 10 to the power minus 13 and put the value of epsilon naught 8.85 into 10 to the power minus 12 into area 90 into 10 to the power minus 4. When you will calculate this, you will get the answer 800 volt per meter. Volt per meter. And we have calculated the electric field. Now we can calculate the small u. Half epsilon naught E square. Half epsilon naught is 8.85 into 10 to the power minus 12. What is the value of E square? 800 square. You can get this answer by yourself. So Hamza, have you understood how we will solve these kinds of questions in the examination? Yes or no?
Yes, sir.
Okay. Have you noted down?
Yes, sir.
Noted na? Here till here. Not,
Yes, sir.
okay. Fine. So you can calculate this by yourself. No problem. So now there is another thing. Like when parallel plate capacitor with air between plates and connected with cell or you can say battery of voltage V0. Voltage V0. And this battery remains connected. Remains connected. And please note one thing, whenever the battery remains connected, the potential will remain same. Whenever the battery is connected, so you can say from here, the potential difference or the voltage between the plate will remain same. Voltage or voltage is also known as potential difference across the plates, between the plates. Voltage or potential difference between plates will remain constant when battery remains connected. Hamza, I am just coming for 1 minute. Battery remains connected. So what now I will do? What I will do? This is the capacitor, and this capacitor is connected with battery of voltage V0. Okay, and this is positive terminal, so this plate will become positive and this plate will become negative. And suppose if I want to calculate the capacitance, and air is filled in between the plates. So capacitance is given by C naught is epsilon 0 A divided by D. And secondly, voltage remains same, means V equal to V naught. And number 3, if I want to calculate the charge is, suppose initially the charge is Q naught, here minus Q naught. So Q is equal to C naught into V naught. We know C naught into V naught. Okay. So here from here we can calculate Q naught. And if I want to calculate the energy, number 4, energy means capital U, half C naught into V naught square. Half C naught into V naught square. This is, you can say this is number 1. Number 2 is parallel plate capacitor, battery remains connected and dielectric is filled in between the plates fully. Battery remains connected. Number 2, not number 2. And write parallel plate capacitor with dielectric fully filled between plates and battery remains connected. So this time what is happening, here is the capacitor, this is the battery, and now a dielectric is filled in between the plate, and then dielectric has a dielectric constant K. So if I want to calculate the capacitance, so capacitance C naught is capacitance when air is in between the plate, and Cm is the capacitance when there is some medium. And we have studied Cm is equal to K times of C naught, means capacitance will increase. Second number is, if I want to calculate the potential, so potential will remain same. V equal to V naught, because whenever the battery remains connected, the potential remains same. Battery remains connected, potential same, that is V naught. So potential V equal to V naught. And number 3 is charge. So what about charge? So charge I am representing when Qm represent charge when dielectric is placed in between the plates. Q is equal to Cm into Vm. This is Vm. Cm is K times of C naught and Vm is V naught, means K times of Q naught, means this will also increase. And what about energy? Energy is U is equal to half U, energy in medium, Cm Vm Hamza, I am taking a break of 5 minutes. Okay.
Okay, sir.
Hello, Hamza. Are you there?
Yes, sir.
So now I'm starting actually. So now you can see here why I am writing UM. UM means when medium is placed, the energy when medium is placed. U naught is the energy when there is no medium in between the plates. Means air. This is the thing. So if you want to calculate UM, you will write half. Cm is K times of C naught. And Vm, what is Vm? Vm is not changing, means V naught is square. So this will become K times of U naught, means energy will also increase. Energy stored. This will again increase. So this is the case when battery remains connected. Battery remains connected. Dielectric constant. Okay. So Hamza, this is the case. Very simple things. We have calculated the capacitance, potential will remain same whenever the battery is connected, potential same. Charge, we have the formula for charge is equal to charge in medium, means charge. Qm represents the charge when charge on the plate when the uh, dielectric is inserted, means some medium, there is some medium in between the plates. So Hamza, please note it down. We will moving forward now. What happened here? There is a parallel plate capacitor. There is a parallel plate capacitor. Now what we have done, we have filled the dielectric in between the plates. and a battery is connected. Okay, and this battery remains connected. And in this condition, we are calculating the capacitance, we are calculating the potential. Capacitance, we know whenever the electric is placed, the capacitance becomes K times of capacitance in air, and the potential will be same, that is V naught. Whenever the battery remains connected, the potential is same. Okay, and charge is capacitance into potential. So capacitance is becoming K times of C naught, and potential is remaining same. So CV is equal to Q naught. So it will increase, and you similarly you can do for the energy stored in the capacitor. Hamza, note it down. Hamza, note it down.
Yes.
And have you understood or not? Have you understood? Please tell me. Got the points? Hamza, have you got my points? What I am saying?
Yes.
Okay, fine. If you are not getting, then what is the use of this class? Actually, I am little bit fast in today's class. Because these are easy things, so we can do these things fastly. So now there is another thing. Parallel plate capacitor. Dielectric field between plates fully, and now this time the battery is disconnected. Battery disconnected. Now what will happen? Please remember this point. Whenever the battery is disconnected from the capacitor, it means that charge will remain same. Charge will remain same. Why the charges remain same? Because charge will remain same, battery disconnected. Why the charges remain same? Suppose this is the capacitor and here is a battery. This is battery, okay? And this battery is giving, what is battery actually doing? What is the work of battery? The battery is simply giving the charge to the capacitor. Giving charge, and suppose this battery given the charge of 5 coulomb, and now you have disconnected this battery. So now no more charge will be given by any source, means the capacitor will have a now charge of 5 coulomb, means charge will remain same after disconnecting the battery. Okay. So now if I want to calculate the capacitance, So I am making the diagram here, drawing the diagram. Like this is capacitor, and now someone has removed the battery. Remove the battery. This is the capacitor have charge plus, and here the charge minus, and remove the battery. So here you can say removed battery. Battery is removed. And here also the dielectric is also there. Here dielectric is filled fully. And this have a dielectric constant K. And capacitance Cm. Cm means capacitance when some medium, M for medium, C suffix M for medium, some medium, that medium is dielectric of constant K is placed, then the capacitance will K times of capacitance when air in between the plates, means capacitance will increase. Why increase? Because K is always greater than 1. K is greater than 1. Not always greater than 1. It is equal to 1 for air also, for vacuum. And here also the K is greater than 1. So capacitance increase. Here, no, there is only capacitance. So second point, voltage. What will happen to the voltage? Charge will remain same. Charge will remain same means charge is Q naught. Charge is not changing. Voltage V naught, potential in air Vm, potential in medium. So voltage in medium is equal to P is equal to Q charge in medium divided by Q by C in medium. And charge is not changing. Charges remains Q naught. And Cm is K times of C naught. So Q naught by C naught equal to V naught. This is Q naught by C naught equal to V naught. V naught by K. So here K is greater than 1 means Vm decreases, means voltage will decrease. Why it is decreasing? Because K is greater than 1. We are dividing V naught with K, which is greater than 1. And in denominator, the K is greater than 1, then overall value will be small, means the voltage will decrease. Number 3 is charge. When you are talking about charge, charge will remain same as we have discussed in the starting, remains same. And number 4 is energy stored. Energy stored. So energy stored, U naught is the energy stored in when there is a air in between the plates of capacitor, and U suffix m is the energy stored when in between the plates there is some medium. There is some medium. So from here, Um I am calculating um because there is some medium in between the plates of capacitor. So this have a formula half capacitance in medium and potential in medium. So Cm is equal to K times of C naught and Vm is equal to V naught by K. From here you can see V naught Vm is equal to V naught by K. And this is the square. So half K C naught into V naught square by K square. So from here you can from here uh, K is gone. K is gone. K is gone. It means we have capital Um is equal to half C naught into V naught square divided by 2K. So for this half C naught, instead of half C naught V naught square, I can write U naught and divided by K. So Hamza, please tell me, the energy will decrease or increase?
Please.
You can write in the chat box. Actually, your voice is not clear.
Please.
Hmm.
Say, please.
Increase this?
Yes. Yes, sir.
No, energy will decrease. Why energy will decrease? Because you are dividing with you are dividing this quantity with K, and K is greater than 1. K is greater than 1. So this will decrease. You can think this like this. When you disconnect the battery, the power source is not now with the capacitor. The power source is now not with the capacitor. So you can think like that, means the energy should decrease because there is no one to supply the energy to the capacitor. Okay. And battery remains connected, then energy will increase. Why this is decreasing? Like you can see here, like U naught. You have U naught, and you are dividing it by 2. Means this overall term will be half of U naught. Means less than U naught, na? Have you understood?
Yes, sir.
Means now you are getting some energy which is half of U naught. Earlier is what? Earlier it was U naught, but now it is U naught by 2. I am saying K is greater than 2. So take any value which is greater than 2, greater than 1. K is greater than 1. So that is why I am saying the energy stored in the capacitor will decrease. You can think this like this. We have disconnected the battery, and what is the use of battery? Battery gives the energy to the, means battery gives the charge, and that charge, due to that charge, the energy is stored in the capacitor. And now you have cut the source of energy, means energy should decrease now. Earlier the battery remains connected, and energy is supplying by the battery is supplying the energy again and again, means the energy is increasing. Now this time what happens, This time you have disconnected the battery, and now we can see from here and disconnected the battery, and you have inserted a dielectric also. So that is why due to this dielectric, the energy is decreasing. Okay, Hamza, have you noted down?
Yes, sir.
Noted till here? Yeah.
Yes, sir.
Okay. So now what I am going to do is I will show you what had happened. You have started from electrostatics. In electrostatic, the first chapter is charges and fields, where you have studied about the charge, and due to this charge you have studied Coulomb's law, when two positive charge are placed, when two negative charge are placed. You have studied the Coulomb's law, when one positive, one negative charge is placed. You have studied Coulomb law. Means due to the charge, the force is generated, and after that, after the force, you have came to know about the electric field, 1 upon 4 pi epsilon naught q by r square. Means this charge, due to some charge, here is a charge and here is the electric field at a distance r. Means this charge created the force. Due to this charge there is a force, and due to this charge there is an electric field, kq by r square, and k is 1 upon 4 pi epsilon naught. And after that, due to this charge, you can take negative charge also, you have studied the potential, and that is kq by r. Means you can see everything. What is the reason behind everything? Charge is the reason behind everything. Charge is the reason behind everything. And after that, charge created this potential. And if you have taken two charges like q1 and q2 and separated by some distance, then you got the electrostatic energy. Means the system of charge created the electrostatic energy also. This is I am just giving the overview what had happened. So we have got the electrostatic energy k q1 q2 by r. Means all the things are happening due to charge. All the things are happening due to charge. And we have now second chapter. In this has been completed. Now we have second chapter. In the first chapter, we have seen that what phenomena can generated by charge. Means charge. What can charge do? Like charge can produce the force. Charge can produce the electric field. Charge can produce the potential, and due to that potential, charge can produce the electrostatic potential energy. And in the second chapter, in the first chapter we have charge and electric field, till electric field, and in the second chapter we have potential and capacitance. We have seen charge created the potential, and till potential, after we have seen after the potential we have seen the potential energy, electrostatic potential energy. Okay, and from electrostatic potential energy we have came to a point where we need to store the charge. Means everything is happening because of charge, and we should have a device. We must have a device to store that charge. And we have already discussed that earth, if you take a conductor of size of earth, then also you cannot store a large amount of charge. For that purpose we made a device known as capacitor. And now there are many types of capacitor: cylindrical, spherical, and parallel plate capacitor. And cylindrical and spherical is not in your syllabus. That is why we are studying the parallel plate capacitor. So now we are at the parallel plate capacitor, means now we are storing the charge, and due to that charge storing, there is energy in the capacitor, there is potential in the capacitor, there is energy, there is potential, there is capacitance, there is new term we have introduced, capacitance, energy. So these things are happening. You can connect the dots. Okay, Hamza?
Yes, sir.
So Hamza, have you noted down this? Hamza, note it. Okay, you have noted. So now Hamza, you can leave the meeting and please revise your notes. Try to study at your home at least for 2 hours in your free time. Okay, Hamza. Now
Yes.
you can leave. Now you can leave the meeting.